Mercury didn't always look the way it does now. In fact, its current state is likely the result of cosmic violence during the solar system's earliest days. Scientists believe Mercury started off much larger with a thicker crust and mantle like Earth's, but something catastrophic happened. The leading theory: Mercury was struck by a giant protoplanet, a Mars-sized body that slammed into it and blasted away most of its outer layers, leaving behind a small planet with a massive iron core. This collision theory helps explain why Mercury has such a high metal content and such a thin outer shell compared to the other rocky planets. Basically, it's a planetary survivor, what's left of a once larger world, stripped down to its core. And because of this unique structure, Mercury offers an unmatched look into the building blocks of planets. Its exposed crust and mantle are like a geological fossil, letting scientists study conditions that date back over 4.5 billion years, almost to the birth of the solar system itself. But even after its formation, Mercury's life remained anything but peaceful. The surface we see today is scarred beyond belief, covered with impact craters, lava flows, wrinkle ridges, and fault scarps, proof that this planet has been battered, reshaped, and compressed over billions of years. Unlike Earth, which constantly recycles its crust through plate tectonics and erosion, Mercury's surface has barely changed since ancient times. It's like a time machine, a planet frozen in time. The sheer number of craters tells us that Mercury has been exposed to countless asteroid strikes, especially during the late heavy bombardment, a chaotic period about 3.9 billion years ago when space debris rained down on the inner solar system. And Mercury's giant faults, some stretching over 600 miles, are proof that it's still shrinking as its core cools, actively reshaping itself from the inside out. These clues aren't just about Mercury, they tell us what early Earth, Mars, and Venus may have looked like before they evolved into the worlds we see today. Even Mercury's orbit is like something out of a sci-fi novel. Because it's so close to the Sun, it experiences powerful gravitational forces that warp its path in space. Its orbit isn't a perfect circle, it's highly elliptical, meaning sometimes it swings in as close as 29 million miles from the Sun and then drifts out as far as 43 million miles. This leads to strange effects, like the Sun actually appearing to rise, stop, reverse direction, and rise again in Mercury's sky during certain parts of its long day. This weird motion is caused by a phenomenon called perihelion precession, and it's so complex that Albert Einstein used Mercury's orbit to help confirm his theory of general relativity. Newton's laws couldn't fully explain the way Mercury moves, but Einstein's equations nailed it, showing how the Sun's gravity actually bends spacetime around it, and Mercury, being the closest planet, feels that distortion more than any other. That makes Mercury one of the best natural test labs for studying the fabric of the universe. Another reason Mercury's orbit is intense is its proximity to the Sun's radiation and gravity. The planet is constantly being bombarded by solar wind and extreme ultraviolet radiation. Unlike Earth, which has a thick atmosphere and magnetic shield, Mercury takes the full force of this assault. Its surface is blasted by charged particles, and its thin exosphere gets continually stripped away and replenished. Mercury's magnetic field helps a little, but it's not strong enough to fully protect the surface. In fact, solar radiation has such an effect that it actually erodes Mercury's surface over time, releasing atoms like sodium and calcium into space. These form the basis of the wispy, constantly changing exosphere. And because of Mercury's fast orbit and slow spin, the temperature contrast between day and night is so extreme it creates thermal stress that cracks rocks and helps shape the terrain. Every inch of Mercury is shaped by violence from both space above and fire within. Despite all this chaos, Mercury remains stable. Its orbit hasn't collapsed, and it hasn't been pulled into the Sun. That balance is part of what makes it so fascinating. Studying Mercury helps scientists understand how planets can stay intact in extreme conditions and offers a warning about what happens when a world lacks protective features like an atmosphere or active geology. It's a reminder that even in a system as old as ours, the forces of gravity, heat, and radiation are still sculpting the planets. And though it might not have oceans, moons, or clouds, Mercury holds keys to understanding planetary survival, destruction, and rebirth. It's not just a scorched rock at the edge of the sun, it's a cosmic laboratory quietly orbiting in the most dangerous part of the neighborhood.